afternoon, everybody. My esteemed panelist, the audience, and Mr. Negi and Resonance for inviting me here. It is a privilege to speak on a subject which was dear to heart for close to 3 decades in my company. I joined in late 70s in Engineers Limited when the pipelines were coming in vogue in India. The first pipeline which we did was for Kudremukh Iron Ore Limited and small work for Oil India. And 79, my journey started from Pipelines Department of Engineers Limited. I was in the design wing of Pipelines Department. HPJ was just getting born and GAIL was formed to execute the job. There was instances where we were told to have foreign collaboration coming in for design and execution purposes so that we become self-sufficient in pipeline design, manufacturing, construction and operation. So we had a foreign collaborator, Gasuni, supporting us for executing. So I belong to that vintage era. All these pipelines are lifelines. HPJ was a lifeline, as well as the connecting pipeline from offshore to Hazara was also a lifeline which feed to all power plants, fertilizers, CGD systems. We upgraded a lot. Since 79 onwards, we moved from coal tar animal to 3LP coating to higher level of cathodic protections and tried to incorporate as much as latest possible technological and commercially beneficial changes to the design and manufacturing, including construction also. So why learning is important? Every learning is a teacher to us, and every incidence is the opportunity to improve upon. To remain in the business, we need to be commercially as well as technologically upgraded every now and then so that we are abreast with the technological changes which are happening in the world, as well as the least cost to the client. So basically, learning from pipeline incidents, safety and reliability definitely is the key one. Risk reduction and downtime. The basic problem in case of incidents, which my colleagues have been referring to, is environmental damage, one, big one, reputation of a company, and a financial loss. Couple of incidences I'll give in the future, in next slides, which will tell you how we have tried to save money for the company as well as for the country. For close to 3 decades, I was part of design as well as selection of line pipe materials in India. The problems came up in design, problems came up in manufacturing, and we were kind of pioneer to bring out Indian industry from slumber and manufacture pipes and newer coatings in India. That was the requirement of the clients, that was the requirement of saving the foreign exchange at that time. So we brought in multiple changes with respect to design, manufacturing, construction, and safety. 3 small incidences I'll just touch on line pipe valve selection, how we upgraded ourselves from 70s to 80s to 90s to 2000, and how manufacturing defects occurred and how we rectified those, and route selection, which my colleague Rajkishore already covered. When we started design in 70s, we were nascent and we were just learning the tricks of the trade, and we used to have a lot of margins coming in. Even the codes had a lot of margins and plus minus tolerances coming in. It so happened that technology upgraded and the coils and pipe plate manufacturers started making manufacturing materials much below the nominal wall thickness. And we found it is becoming very marginal. The moment we used to have design coming in, we used to have API 5L selection, which used to give us some margins. But it so happened that to get commercial advantage or reduce the overall tonnage, we came down to having, in case my design is indicating 7, I'll just go for 7 mm thickness. But the court still allowed those negative tolerances, and the upgradation in the material manufacture brought in, everybody went below nominal. All the pipes which were being sent to us from abroad or from even India were having much lower than the nominal thickness, which were becoming safety hazard, as well as during cold bending, we were not able to get those margins. So we changed the specification and brought in 0 negative tolerance in the specifications. My colleague will confirm whether we are still continuing or not. That was the way to ensure that everybody at least meets the minimum nominal wall thickness and safety integrity is kept. One of the pipelines which we were doing for GAIL, after completion of the laying, we went for hydro test, and the design pressure was close to 90 bar. At about 35 bar pressure, one of the pipes opened up during field hydro test. We replaced that pipe. It was a take-off pay for a power plant, and power plant was to be commissioned in next 10 odd days. We went to, after repairing, we went for the next hydro test, and cyclic hydro test, another 45 bar, another pipe gave away. So a call was taken to derate, as well as the capacity of the pipeline was reduced. Basically, that was a EIL pipe which had a cold weld, and weld started opening. So modification in the specification for manufacturing and design was changed. Along with chemical composition, having more ductility coming in, as well as induction frequencies were changed so that there is no cold welding or cold stitching. So that modified the pipeline, line pipe requirements, and we could, of course, that pipeline has to be re-rated. But future, at least, we could take care of by introducing multiple methods, which included that during manufacture, we need to have a burst test coming in, because we do testing of 10 to 15 seconds during manufacturing stage. So we brought in a 24-hour test for the new mills or existing modified mills, as well as field hydro test simulation or burst test to be included into the manufacturing area. Route selection, already my colleague has touched. Amba Ghat we designed after we had already a failure. Something similar what you see, pipe on the ground, straight pipe, we pulled it up for about, that pipeline was close to about 45 to 50 degrees vertical. And next monsoon, it became a channel, and the water flew away and removed each topsoil of the pipeline. Even though we have slope breakers over there, of course, the design could have been better to ward off that issue. So we modified the systems. We brought in the zigzag lave system, as well as better slope protection, better backfilling, engineered backfill to come in to solve the problem. So in the conclusion, every challenge should be taken as an opportunity. And we must ensure that we modify our requirements in the specification, design, manufacturing, as well as during construction, bringing in the new technologies. Like now we have digital twins, we have now automatic welding, now we have digital radiography. So these newer methods, I hope, will bring much safety and integrity to the pipelines. Thank you.